So buttons and logic. To take a step just backwards for a second and define something important in programming, all of the programs that we've been writing in which we've attached a listener to a display object, for instance, to listen for a tap or a touch, these have been what's known as event-driven apps. The user's action of tapping or touching the screen is an event, and we can write programs that listen for events and respond to them in some way that's appropriate to the nature of the event. To make an event-driven program, you need to identify what you want to listen for instance, a shape or a button or another widget of some kind, and specifically what type of events you want to listen for as well, be it a touch or a press or a release. And then you have to supply one or more functions to handle events when they occur. So for instance, when a tap occurs on a display shape, we'll provide a function that does something. We've written apps that do lots of different things, but that count or move around the screen, initiate a transition maybe, display some piece of text in response. So we've been writing event-driven apps for a while without necessarily really knowing it. But once you start looking at widgets and adding widgets to your app, then you're guaranteed that your app is going to be event-driven, and you'll need to follow this event-driven sort of model. But there's actually nothing new about this. We've been doing this for a couple weeks now. So there is a little bit of a difference between an event-driven app and a non-event-driven app. In the earliest apps that we wrote this semester, the code would execute from top to bottom. It would do its work and it would be done. It would be complete. It would spit a result out to the console, for example, and then it would exit normally, not a crash. It was just done. That's not the case in an event-driven app. In an event-driven app, the app remains resident in memory and running and listening for events that you've indicated that you want it to listen for. So it executes certain code to set up its UI, does whatever programming work you've coded, say in the main stack, and then it just waits. It waits for a tap, or it waits for a touch, or whatever specific event you're listening for. It waits for that, and when it hears it, when it sees it, then it responds to it by executing the function that you've written to provide the code to respond appropriately. The flow of execution is similar to what we talked about last time, in that the event will trigger the execution of a function. So the flow of execution will then jump to the function and execute that function. And then in most event-driven apps, it will go back to waiting at some point. It will do whatever is appropriate in response to the button press, say, and then it will return to its waiting and listening state. There's nothing we have to do as the programmers to make this happen. That's done automatically by the Lua interpreter or the Solar 2D interpreter. So there's a lot of stuff that you can listen to and lots of stuff that you can listen for. You can listen to all of the basic shapes that we've talked about and images. You can attach listeners to that, widgets. You can also attach a listener to the running app itself. You can also attach listeners to transitions, sounds, timers, and physics bodies, which we'll get to later in the semester. And you can listen for a lot of different types of events. You can listen to a tap or a touch, some sort of interaction with a widget. You can get the location of an event if that's important. Lots of events also have discrete beginnings and endings, which you can listen and respond to if that makes sense for your app. You can learn about the identity of the object that was part of an event. This becomes important, for instance, when we get to physics and we start learning about collisions, then we'll want to know what collided with what. That becomes important if we want to, for instance, if it's a game, we want to know whether the ball has reached the goal or the bomb has reached its target or whatever it may be, so that we can respond appropriately to a collision. We'll need to know a lot about the collision itself. And there are also certain runtime events that we can listen for as the app itself is running that we'll also get to later in the semester. All right. There's actually 3 different types of buttons, at least 3 different types of buttons. I organize them into these 3. There's the text button, the shape button, and an image button. And I've got screenshots of each of these, and there's running examples of each in the chapter downloads. But you can kind of see what the difference is just by looking at this. The text button is just text. The shape button is text with a shape of some sort behind it. And then the image button is composed of images. So it looks kind of similar in these screenshots. The image I use offers a little bit more kind of a 3D effect, what you call a skeuomorphic effect. Most of the tutorials on Corona and Solar 2D create a button that, when activated, when the user does something to it, it creates actually an event with 3 phases. There's a began phase when the user depresses the button. There's actually a moved phase that's reported if the user moves their finger while pressing the button. And then there's an ended phase when the user lifts their finger off of the button. So by default, most of the tutorials I've seen create their buttons this way, and it results in not a problem, but a small challenge. And if you've written it this way, you'll need to detect which phase of the event occurred and respond to the phase that you want to respond to. For instance, if you wrote an app that was counting, so that when you tap the button, it was supposed to count up by 1, if you weren't careful, when the user taps the button, you could get 3 phases. And so you might count up 3 times potentially, or if their finger doesn't move during the press, 2 times at least. So that's often a point of some confusion, but there's an easier way. Instead of listening for all possible button event phases, you can limit yourself to one of them. So you can listen, for instance, to on press, and then when the user presses the button, it will generate an on press event, and your listener will get the on press event and know that the button was pressed and execute 1 time. It does not matter then if the user accidentally slides their finger on the button or purposefully does, or it does also not matter when they release the button, because you're not listening to those extra phases. So Drawn to Code uses on press by default because it gets around this need to worry about and control for potentially 3 different phases. There's another issue, which is, how do I write apps that have multiple buttons or any of a particular type of widget? And one way to write it would be to attach all your buttons to whatever listener you want, be it on press or on event or on release. And then in a single event handling function, use if-then logic to determine which of the buttons was pressed and to reply to it. And the other way to do it, and to some extent the easier way to do it, is to attach the listener to each of your buttons and then give each button its own event handling function. And that's the default approach I use in Drawn to Code. As an example, if we added a button to our UI, adding a text button here, if we have a completely empty stack, then you'll actually see we get 4 script objects added to the stack. There's the button itself, object 1. There is the event handling function, which is object 2. It's called object 1 on press handler. There's a default snippet, object 3, which contains code that tells you something about the press. And then there's a require statement, object 4, up at the top of the stack. So to use any of the widgets, we'll need a line of code in our stack that is really simple. It's a single line of code. It just says widget equals require widget or something along those lines. So Drawn to Code will add that statement if it's not there for you. So the shape button is very similar. And so in this example, I've added a second button. So we still have our text button, object 1, but I've added a shape button now. And you can see it adds 3 script objects to our stack. Object 5, the shape button itself. Object 6, the event handler. Object 5 on press handler. and a default snippet for the shape button. It does not add a second require statement. It doesn't need a second require statement. You only need one require statement for all widgets that you're going to use in this stack or in this main.lua file. But if you look at the code, you'll also, or the stack, you'll note that each button has their own dedicated event handling function. So there's no need to try to figure out which button was pressed, because you know which button was pressed in each of the event handlers, because it's dedicated to just that button. It makes some sorts of programming much easier to do it this way, although on occasion you will get to the point where you think, well, no, I really need to consolidate, handling of these buttons together in a single function. And if that's your need, that's easy to do as well. There's a way in Code to reassign the event handler for any widget to any function that you care to name. All right, the text button. We can talk about this, and then we'll jump over to Code and do it. I have a few examples in the chapter downloads that are kind of designed to be just a little bit cool. And this one is a screenshot of one of them, in which it waits for you to tap that text button and then uses a transition to fade a response message in, and then after a delay phase it back to the waiting message that you see in the screenshot. So it's, obviously stuff that's fun is fun, but it's also more complex. And so when we do an example in Code, we're not going to make it as complex as this. But the text button, you can see it really is just text. That's the button where it says text button. So this is considered a newer design style. It's a flat design, or also called non-skeuomorphic, which simply means it's not trying to look like something physical. It's not trying to look like, say, a piece of glass or wood or metal or anything like that. It's literally just text. It does get its own color, which is by default this sort of light blue. It's not trying to look 3D. It's not trying to look like anything, in fact. And to some extent, that's also its disadvantage, because to some people, or in some UIs, it doesn't look like a button. It just looks like text. It's also not entirely clear from looking at that where you could tap. Do you have to tap directly on the text, or is there a region somewhat around the text that you could tap on? That's probably the central criticism of that style design, is that it is unclear, and that there could be actual areas to the left and to the right of the text button that you could tap that would activate the button, but would also be maybe inappropriate because the user didn't actually tap the button. They tapped next to the button. I'll show you that in just a second. But without a clear border of any kind around these text buttons, it can be tricky for the user to know both that it's a button that they could tap, and where or how close to the text do they need to tap to activate the button. Let me jump over to Code and share my screen. I've just got an empty Code window there, and so let's add a button. A button is a widget, so it's in the widgets palette. And so Code currently supports these 3 types of buttons, and along with several other widgets, some of which we'll cover this semester and other ones we won't get to, but they are there at your disposal. The scrollable table list and the picker wheel I've saved for later development. One, because the table is much more complex to do, and the picker wheel, the implementation the last time I tried to use one in Corona, I thought was quite poor. So I've just saved it, hoping that they'll improve things before I implement a solution in Code. In any event, if we want a text button, you can just press on the button text button right up at the top of the widgets stack, and you'll get this button text on screen, just like in the screenshot pretty much. And if you look at your stack, let me zoom in, you'll see you've got the promised 4 script objects. So I'm going to save it into my work folder, and I'm going to create a new folder for chapter 5. I'll call it chapter 5. And then I'll call this design just text button. All right, the code that's generated is not huge, and it also matches or should match what was in the screenshot. earlier, but you see here's the button. The button is set up with a table of key value pairs, and all of these you have control over in the settings panel in Drawn to Code. Here's the function, object one on press handler, and the default snippet inside of it is this. Yep. There's the require statement. This won't be terribly exciting. The simulator just displays this one button. It's helpful to know that it's a button since it says button. If it said something else, you might not be sure whether it was a button or simply blue text, but it is a button. If you tap it, you'll get the promised message. When the user presses the button, it generates an on-press event, and Solar 2D then takes that event and passes it to the event handler, object one on press handler, to do with what you wish as the programmer. If we look at the button, you'll notice it does have an outline around it, so it's got a width and a height. If you programmatically made it larger, it would create an area around the text that could be tapped, but that didn't contain any text, which can get confusing. So in Drawn to Code, I've changed it so that whatever text you type in, the shape just surrounds it so that you can't accidentally create these sort of invisible areas that are tappable. You could override this by setting width and height attributes, say using a snippet if you cared to. Otherwise, this tends to create the most useful size text button. I'm going to move this up. Let's add the second button, which is the shape button. So you click button shape and you get this default shape button. So in Drawn to Code, I use that same blue color by default, but you can change that. Shape buttons are allowed to have a stroke around them, an outline line that you can set the color on. So you can have a fill color and an outline color. You can control the font. You can control the size of the stroke. I default at 4 pixels, which is okay for really large buttons, but for smaller buttons, I normally make it a little bit smaller. Let's save it. Double check that the code that's generated looks like what you expect. So this matches the screenshot we just looked at. Here's the shape button. These are obviously a little bit more complex to set up. You also have control over the rounding of the corners. And if you don't want corner rounding, you can just turn this radius all the way off, and that will get you a square shape button. Here's the new shape button. Here's its event handler. So it's a separate event handler, and you can see the snippet inside of it says print you pressed object 5. So code inside of this object 5 on press handler is dedicated to that button. Pressing the other button will not get you into that event handler. There is potential for a little bit of a difference between how Java renders around a rectangle and how Solar 2D draws the rounded rectangle. And so you just have to play around with it to get the exact effect that you want. But if you are happy with the way it looks, if you hit the buttons, what you'll see is you pressed object 5 when you press the shape button, and you should see you pressed object 1 when you press the text button. All right, so we talked about the text button. We just showed you the shape button. And so the most complex one I've implemented in Drawn to Code is the image button. Pretty obviously, the image button is a button that uses an image. But specifically, it uses 2 images. So there's an image that you use to display the button in the UI, and there's a separate image that you use to display when the user is pressing the button. It could be the same image if you don't care to have a separate pressed image. It could be something that's just a variation. So in this example, in the images in the download, I've created 2 buttons. Press button just a little bit darker to maybe give you the sense that it's being depressed. But if you were really good with Photoshop or one of these Illustrator tools, you could create a much more sophisticated depressed effect that was different from the default or undepressed effect. For the image button, you do need to supply 2 images though. So yeah, Solar 2D, Corona refers to these as the default button and the over button, which I bring up just because you'll run into this terminology in Solar 2D's documentation and also potentially online tutorials that you might find on buttons. I always have found this an odd label because it's the unpressed and pressed states. It's the unselected and selected states. Those terms all make sense. The over state doesn't really make any sense to me because the device doesn't know if your finger's over the button or not. In desktop programming, you do know that. In desktop programming, you can track the mouse pointer, and you know when the mouse pointer is over something. And so having an over state in a mouse-based UI makes sense, but having an over state in a touch-based UI seems a little bit confusing, at least given the current technology that doesn't track your finger. Maybe in the future, our devices will track our fingers, and it might make sense to have an over state. But at least at the present time for what we're coding and what Solar 2D does, although you can call it over, I normally call it pressed. So default and pressed. And the other issue, maybe small issue, is that Solar 2D doesn't really come with a stock supply of buttons to use. There are a lot of buttons, though, in the download in Solar 2D if you look in the sample code it comes with. So if you scan through that, you'll find a number of apps that have buttons, and all of those images are completely usable for your project. I would say you'll want to copy them into the project folder, just like any other image or resource. And Drawn to Code will offer to do that for you as well, to be helpful. So let's jump over quickly to Drawn to Code and see what the image button looks like. Let's add an image button. So you press the button image button. I should have moved that first, but what you get is this button text. So the label on all the buttons is just called button text. But then you get this big red X on screen, which scares people. And I drew it like that to get your attention so that it's not ready. It does not yet work. So the red X tells you you've got something else you need to do, which is select your images. So in the settings panel over here, you'll see there's two buttons, default image and pressed image. So that's how you set them. So we'll set a default image. Now I don't have an image file in here, but I do have one in documents. Got a folder with resources and images, and a lot of images. So I've actually named these particular images button and pressed. So if you'll select button and then select your pressed image and go back and find the pressed one. These are obviously also in the chapter download for this chapter. And I, from this point forward, use image buttons a fair amount. And I use these same two images all the time, so they'll be in lots of the downloads. Now I gotta find it though. There it is. Alright, so if we save that design, you should get, if you're following along, you should get a third button, which is the image button. And if you press it, you'll see at the console that you pressed it, the object date. So if we look at the code, hopefully it's exactly what you'd expect. So each of the buttons now is these kind of large key value pair tables. So this is the image button. This is the shape button. This is the text button. And then each button has its own event handler. So there's the event handler for the image. Here's the event handler for the shape button. And then at the very top, here's the event handler for the text button. So each button is set up separately as a distinct object, is attached to the pressed listener, and has their own dedicated press event handling function. If you peek at the code, you can see where that is. It's, all right, let me zoom back in. Here we go. The key value pair at the very end is onPress equals, and then the name of a function. So each of the key value pair tables uses onPress to connect their button to a specific event handling function. If you wanted to connect them together in some way, if you decide, well, no, I really only want one event handling function and I'm happy to use if then logic in there to kind of sort through it, then what you do is select any one of the buttons and then use this button inside of its settings panel, reassign handler function. So you could pick one of the functions to use if you wanted to do that and then retarget them all to it, or you could create a new function using the functions palette and then essentially repoint all of the buttons to that function if you wanted to. But probably for 90% of what we do in class, it actually is easier to have separate event handling functions for each widget. And when we come to a point where it makes more sense not to, then I'll show you how to do that, step by step, so that it's not a mystery. Not that it's necessarily a mystery, but so that it's easy. The issue with the image button is it really needs to be made dedicated for the size in your UI, because if you scrunch it, let me jump back to drawn to code. I shouldn't have switched. If you select the image button and let's just resize it, let's say I really want a small button. What you'll notice is that the corners now are all scrunched up. It gets compressed. And the same thing would happen if I said, no, I really want a pretty wide button. At some point, the corners are going to get stretched out and not look right. Ideally, you'd have a dedicated image for all the different widths in your app. Or you could use a more complex syntax, which allows you to create slices of the image for the button that Solar2D will assemble for you and make look correct. I don't support that multi-slice image button in drawn to code, though. All right. So we've covered the concept of event-driven programming, and then you've learned your first widget, which is the button widgets. So there's 3 different types of buttons, major types of buttons in Solar2D. I think you're now a master of events and of buttons, and we'll turn our attention next time to some if-then logic, and then we'll create an app that obviously uses buttons to count and to reset the counter and stuff like that. So kind of basic, fun programming stuff using buttons next time. All right, that's where I wanted to get to.